Hello, my love bugs and my not love bugs if you are watching this from one of the other teachers' classes. Hope you guys had a good weekend. Hope you are staying warm. Hope you got to enjoy the snow a little bit. And at least you got another digital day out of it. So, our last lesson before we hit review day for our test is again going to be with systems of nonlinear systems of equations. So last week we talked about how linear equations were two lines that intersect, or well, yes, systems of linear equations look like these. But then we introduced to you guys nonlinear systems, which just means that a quadratic equation is somewhere in the mix, or it could be a cubic function or something else. But right now we were focusing on quadratics and linears. Well, today, had we been together, we would have seen what happens when you mix quadratic and quadratic, when you have two parabolas all in the same graph. And very much like when you guys saw systems of equations, if your two lines did not touch, that would mean that there's no real solution. If they intersected one time, that would mean they have one real solution. If the lines lied on top of each other, we would call that infinitely many solutions. All right. So we can apply that same logic to our quadratic systems. All right. As you can see here in your notes on page 18, no real solution, the quads don't touch. One real solution, they touch at that single point. Two reals, they cross just two times. And infinitely many solutions means that we have two quadratics on top of each other forming that U shape. All right. And just like we saw with a quad and a linear equation, you can solve these algebraically. You can also solve them graphically. All right. So I'm going to show you the graphical way first, just because I think I'm going to have to split this up into two videos just to make sure that they're not overwhelmingly long. All right. So we want to solve this system of equations. Solutions are where they intersect. So I'm going to pop over to Desmos real quick, and forgive me for switching back and forth if you're not used to that from me. We have x squared. I think that was plus 3x minus 5 plus 3x minus 5. And then my other equation I know was a negative x squared plus 10x minus 1. So when I zoom out, these guys touch here and there. So I think that these two intersection points are my solutions, negative 0.5, comma 6.25, and 4, comma 23. So that's how you would find it graphically. Look for the points where they cross on the graph. So I'm going to pause this recording here, and then I'm going to start it again in just a moment to show you the algebraic way.